A community estimate pulled from reverse engineering the Claude Code codebase puts the split at roughly 1.6% AI decision logic and 98.4% operational infrastructure. That massive disparity in code volume forces system architects to reconsider how autonomous systems are actually constructed. When the vast majority of a codebase is dedicated to the environment rather than the brain, the engineering priority shifts. Anthropic designed Claude Code as an execution environment first. The reasoning model functions as a swappable component housed inside that infrastructure, rather than the infrastructure existing as a simple extension of the model. This is a massive, strictly governed operating system that happens to contain an embedded language model. Maintaining this level of infrastructure is what enables the scale required for Nicholas Carlini's $20,000, 2,000-session autonomous runs. Producing a 100,000-line compiler requires a harness capable of surviving that much accumulated adversarial context. I am Bearded AI Guy, and today I am working through the architectural analysis of Claude Code assembled by the human architect. We are pulling directly from Anthropic's engineering posts, the Agent SDK documentation, and the broader competitive landscape. In 2026, competitive advantage no longer stems from raw model intelligence. The defining factor is where engineering teams choose to allocate their non-model complexity budget. Claude Code serves as the reference architecture for this shift. Anthropic explicitly built the system as a structural harness, providing a durable environment for models that act as reasoning engines. Every major coding agent product placed a different bet to solve autonomy through infrastructure. Cursor isolates parallel cloud agent runs using Git worktrees. Factory organizes its architecture around strict orchestrator, worker, and validator roles to prevent context degradation as tasks scale. Anthropic documented Claude Code's design openly. By publishing their engineering decomposition, they transitioned Claude Code from a proprietary internal tool into the industry's reference architecture. The published structure defines 5 functional layers: surface inputs, core agent loop, safety policies, state management, and the back-end execution environment. The build exposes immense scale within those layers, including up to 54 built-in tools, and state persistence managed through append-only JSON-L transcripts. The Agent SDK documentation confirms that external users get the same loop, tools, and context management. Anthropic is standardizing this operational harness as a reusable substrate for the entire agentic ecosystem. Imagine hiring a brilliant contractor who has severely limited short-term memory and zero recall of yesterday. You cannot give them direct, unmonitored write access to your production servers. You do not attempt to retrain the worker. You construct a highly restrictive, structured office around them to enforce permissions and carefully record every action they take. That office is the direct architectural parallel to Claude Code. The model is the isolated worker. Everything else is the surrounding office. Anthropic explicitly names these components. The harness handles context assembly, memory compaction, strict permission evaluations, and the orchestration of isolated subagents. The system extends external capabilities through tool pool assembly and dispatch, pulling in extensions via the Model Context Protocol, plugins, and custom skills. The model performs a single solitary function. It decides what to do next by emitting a tool use block. The harness takes on the responsibility of routing that action, validating its legality, and managing the state persistence for the next loop. Intelligence is quarantined within the model. All actual systemic capability and execution power resides strictly within the surrounding harness. The central query loop functions as 3 sequential, gated doorways that every request must pass through. The first door is a strict filter. It determines exactly what prior context the model is allowed to ingest before it begins reasoning. The second door is the model itself, executing its logic solely based on that filtered slice of context. The third door is the ultimate validation checkpoint. It intercepts the model's requested action and evaluates it against system policies before allowing it to run. Anthropic's loop architecture translates this directly into code through 3 injection points. First, the assemble phase dictates what the model sees. It compiles the system prompt, the loaded tool surface, memory bounds, and hook injections into a tight package. Finally, the execute phase controls whether actions run. It relies on deny first permission evaluation and a hook system spanning 27 distinct event types that can block, rewrite, or annotate actions before they touch the system. This tripartite loop maps directly to a definitive root cause debugging framework. System failures are strictly categorized into 3 buckets: bad context assembly, bad reasoning choice by the model, or bad action policy in the harness. System designers often default to human-in-the-loop approvals to secure autonomous systems. The data shows this is a behavioral vulnerability. This chart shows internal Anthropic metrics measuring human oversight. When Claude Code stops to ask a human to approve an action, the user says yes about 93% of the time. Approving almost everything mechanically is not supervision, it is rubber stamping. That shifts the burden of safety entirely onto infrastructural containerization. Anthropic's engineering solution implements strict file system and network sandboxing to physically restrict the agent's reach at the OS level, regardless of human approval. Internal telemetry showed that by deploying the sandboxing architecture, they eliminated the need for 84% of all user prompts. Classifier-mediated boundaries and strict file system constraints provide mathematically superior safety guarantees compared to a manual approval bottleneck. True autonomy is achieved strictly through infrastructural and network containerization, not by asking users for permission. When a main agent executes a complex multi-step task in a single conversational thread, the context window inevitably degrades through adversarial accumulation of errors. If a junior employee reports back to you by reading out every single keystroke and mistake they made over the last hour, your own working memory is quickly exhausted. Claude Code solves this delegation problem mechanically. It dispatches specific explore or plan subagents directly into isolated Git worktrees. These subagents share no prior context. They execute in a sealed environment to prevent context pollution. When the subagent completes its task, strict protocols ensure it only sends back highly compressed summary artifacts to the parent loop. Scaling AI agents relies entirely on maintaining pristine contexts through isolation. You do not solve complex tasks by cramming more agents into a shared environment. You solve them by enforcing fresh contexts. The Claude Code architecture is best understood through the lens of classic, decades-old operating system design principles. Classic OS designers created durable abstractions, processes, file systems, input-output, to outlast the software running on them. Today's AI engineers must prioritize durable abstractions, like sessions and sandboxes, over brittle, model-specific prompt optimizations. System architects should identify and delete model-specific optimizations from their codebases. As baseline model intelligence naturally improves, those temporary patches become deadweight that hinders long-term portability. By 2026, engineering success depends on constructing durable, swappable operational interfaces. While prompt techniques fluctuate with every model update, these structural boundaries remain stable. If you want more architectural deep dives into the systems running underneath the models, subscribe to Bearded AI Guy. Drop a comment below and tell me which architectural concept shifted your perspective. Was it the 93% human rubber stamp rate, or the necessity of summary-only subagents? I read every comment. Remember the programmatic reality of modern agents. Reasoning lives exclusively in the model. True execution lives permanently in the harness. I will see you in the next one.